Just to get things started, by the way, I was observing this before, so I was like, you know what, I'm going to do the smart thing, and I'm actually going to copy my presentation to a USB drive. And I sat calmly while the presentation was getting up. And so then I lost it. I lost my USB drive. So all the preparation. Anyway, so my area of passion for the last 13 years has been studying a group of organizations that we used to call geniuses of people with great kung fu, right? So I've been studying these organizations since 1999. So what made these organizations great? They had great project due date performance. They had great operational stability and reliability. They had a great posture of security, and they had a great posture of compliance. And so one of the questions that we wanted to ask is like, what is it that they're doing so differently that's resulting in their phenomenally great outcomes? And so one of the things that made us sort of fall off the chair kind of first is actually kind of asking, where did these high performers come from? And one of the things that we saw right away that we thought was very puzzling was, if you looked at who were the people leading these high performers, they typically came from one of three professions. They were either a non-commissioned officer in the military. Yeah, here. Oh. Oh, gosh. Bang. Thank you so much, Mike. They were either non-commissioned officers in the military. Okay, great. That has to be plugged in. So they're E5 or E6s. So they're a staff sergeant or a sergeant. They were a chemical engineer in the or a nuclear engineer, or they were an auditor, not just any green eye shade wearing bean counter, right? They were an IT auditor. So can anyone speculate what these three professions have in common in terms of the values that they hold near and dear? Non-commissioned officers in the military, chemical engineers, and auditors. What was that? Discipline. I love that. Any other words? That's really good. High outage cost. Yes. Any others? The words we came up with was, after many years, was rigor and discipline, right? And so if you take a look at why this might be, right? Non-commissioned officers give live ammunition to 18-year-olds. And what I've learned in my journey is that if you go into restaurant operations, they don't even like giving knives to 18-year-olds because you combine knives and raw carrots. The accident rates are so high that the insurance companies get involved. Chemical engineers have long, elaborate recipes where if you missequence 2 steps, right, endothermic becomes exothermic, right, and people, things can explode. We had a joke at Purdue University. How do you tell if someone in the engineering department is a nuclear engineering professor? Count their fingers. If they don't have all 10, they're a nukie, right? And auditors, they haven't met a control or a checklist they didn't love. Right, and so over the last, from about 2005 to 2008, I helped raise about $1 million to benchmark over 1,300 IT organizations to see if we could link controls with performance. Right, and we actually found that rigor and discipline pervaded those. Those three things almost predict performance. And so that's what we put into the VisualOps handbook that we published in 2004. So where this journey has taken me, against all my expectations, is that it's taken me straight into the heart of the DevOps movement. And so I want to share, and I think it came for me at a very special time, right? Because I started seeing something that happened in almost every IT organization. This downward spiral that it didn't matter whether you were in an enterprise or in a small shop. It didn't matter what vertical you were in, large or small. There was a terrible downward spiral that happened in almost every IT organization. So what I want to do right now is just share with you what that downward spiral looks like, and it can be told in 3 steps. And it starts off in IT operations. Right? How many people here would call your sort of primary kind of passion and vocation ops? How many people would say your primary passion and vocation is dev? Right, okay, and then security? James, you're out there somewhere? Right, me too. I'm one of the information security people, right? So the Act 1 begins in operations when we're put in a situation where we're having to support fragile infrastructure in production. The reason why we call it fragile is because if you even look at this application or this piece of infrastructure, right, or this interface, it blows up and no one knows how to fix it, right? And no one knows how to build a new one. So what happens is that there's a terrible tragedy, right, is that these most fragile artifacts and services typically underpin the most important business initiatives for the organization, right? It might be the most important business project. It might be the business operation, right, with the highest outage cost. And so when you have the most critical operations and projects relying on things that are fragile, something awful happens, right? The company starts missing the commitments it makes to the external market, right? Sometimes it's a promise they make to the customers, sometimes it's what they make to Wall Street, sometimes it's promises they make to the analysts, right? And so when that happens, typically I think it's just part of human nature is that to atone for that, right, we make even larger, more audacious promises, right, to compensate for the commitment we just missed, right? And so the tragedy is that these commitments are often made by these people, right? The product managers, right? Often art majors, creative writing majors. And by the way, some of my best friends are art majors. But they often don't have the best innate understanding of what technology can and can't do. So now we enter Act 2, the developers, right? And just if I could explain this image, right? If we have a joke in ops, show me a developer who isn't causing an outage, I'll show you one that's on vacation, right? And obviously in this crowd, it's not about developers, it's the DBAs, right? It's the DBAs who cause all the outages. And as a former developer, I say that with love. So what Dev now sees are urgent, date-driven projects put into the queue, right? Where a commitment has already been made to the outside market, right? So the date cannot move. And so when this happens, Dev typically spends all the time working on features, leaving no time for the non-functional requirements, the operational requirements, like, for example, operability, manageability, deployability, security, right? And so everyone who's after Dev, including test, capacity testing, InfoSec, operations, basically the buffet becomes empty, long before it comes to us. Right, so when that happens, this is where technical debt starts to accrue, right? And so when I visualize technical debt, this is kind of how I envision it, right? It's like, and it's not just, so it means that at the end of every project, we have one more piece of fragile infrastructure in production, right? And so, this is bad, right? But, we call it technical debt for a reason. Technical debt accrues, right? Just like financial debt. So this eventually becomes this. Right, and so if you have an outage, right, and it's because of a cabling error, right, somewhere between the SAN and the database, which cable is it, right? And by the way, it's that one, right? So, but there's something even more insidious that happens in a downward spiral, which is that things that used to take things take longer to deploy. So we all had an application that used to take 5 minutes to deploy, it takes 10 minutes, it takes a half hour, it takes an hour, it takes 2 hours, it takes a day, it takes 2 days. By the way, has anyone observed this phenomenon where applications take longer to deploy? How many here have a friend who've been in a situation where this has happened? Yeah? Okay, great, thank you. These loops are positively reinforcing. In other words, the worse it gets, the less you do them. In other words, the business will often say, the release was so painful, we're going to do it less often. Right? So we're going to lengthen the deployment intervals. Right? So that's like someone saying, gosh, running that mile was really tough. Let's do that less often. Right? I think that, I'm not sure what the rationale is. Like, somehow we're going to be better rested for our next run. But, so when this happens, suddenly this is what causes operations and development to be constantly at war. Right? So this is kind of the way I envision the guy who just did the code commit, right? High-fiving each other in the parking lot, not realizing they just set the entire data center on fire, for the entire weekend. Right? And so the real tragedy here is that at this point, no one is actually achieving their goals. Developers can't get their features in production, right? Testing is getting farther and further behind. Operations is having more and more time keeping the service up, right? And technical debt is going to guarantee that's going to get worse. And by the way, let's not forget about the information security people, right? By the time they get involved, right, the buffet table is empty, right? And now information security is spending time on the activity that has the least nutritional value, which is compliance. Right? Instead of making systems and data secure, they're just going through the checklist, right, for someone else. And so this is why the reason this is so important to me is that I think when people are in a situation where this occurs, this puts us all in a situation where we feel trapped in a system that preordains failure, right? And if you're downstream, if you're in operations or information security, right, you feel a sense of hopelessness and despair, right? Because we've actually removed the ability for them to actually change the outcomes. So how many people here at least resonate with at least some elements of the story? Can you just raise your hand? Okay, great. Even the upstream guys. Oh, very interesting. So, and so this happens in almost every organization. And the reason is that I think every organization, whether large or small, is faced when IT is faced with two conflicting needs, right? The need to respond to urgent business needs, which means deliver features faster and faster, right? That's often embodied by dev, right? On the other hand, we want to make sure that sites are reliable, stable, secure, right? Comply with all contractual obligations and regulatory requirements, right? And that means making no changes ever, right? Over my dead body would say the head of operations, right? Which I've learned can quickly be arranged, right? Because time to market always trumps stability and security. So why every company? It's because every company is an IT company, regardless of what business they think they're in, right? And I think these numbers show why that's true. 95% of all capital projects have an IT component, right? You can't make any business decisions, right, that doesn't result in at least one IT change. And if you look at the capital spend, where dollars are being spent, 50% of capital spending is technology related. So any notion, that IT is not a core competency, that dev and ops aren't a core competency, is just a myth. And I think the visceral kind of proof point of this is that whenever someone in the business says, we're here, here's where we need to go, who's typically in the way? It's us, whether we're in dev or ops, right? Somehow we've constipated the flow of work, right? And we're now jeopardizing or impeding what the business wants to do. So Act 3 says, there really must be a better way, right? And so when historians go back and say, when did DevOps really come to be, right? I think historians will say it was here, right? It was the kind of the famous Allspaw Hammond presentation that was given at the Velocity Conference in 2009, one of my favorite conferences to go to. And so they gave a seminal presentation that said, we are routinely doing 10 deploys a day, at Flickr, right? And who are Allspaw Hammond? Obviously, he's the head of, Allspaw was the head of operations for Flickr, and Paul Hammond was the director of engineering at Flickr. And I think, had I been there, right, my first Velocity conference was in 2010, I think here's how I would have reacted. 10 deploys a day, that's immoral, right? That's irresponsible, that's reckless, that's absurd, right? And I think what I learned in the Allspaw Hammond presentation is that, that's absolutely not true. In fact, I think this is absolutely going to be the way we're all going to be working in 10 years, right? And the ones that who figure out last will be the ones who are actually going to lose in the marketplace. So, this whole notion of, dev being the embodiment of, Spock being the embodiment of dev, I just love, right? He actually gets to sit on the bridge with Captain Kirk. Captain Kirk actually asks him for advice, whereas we ops guys, we're like Scotty. We're stuck in a basement, right? No one asks for our opinion until the warp engines are, down, right? Scotty, we need warp speed now. Captain, we can't do it. Damn it, I need warp speed now, right? So, what they were saying is that we need boundary spanners. We need ops people who can think like developers, developers who think like ops people, and by doing that, it doesn't just result in a torrid summer of love, right? They actually achieve things that the world had not seen before, right? And so 10 deploys. I think what's interesting to me is in my journey of studying high performers, what we found is that the best always get better, right? The best always accelerate away from the herd. And I think that's absolutely happening in this space as well. So back in 2009, 10 deploys a day was considered fast, right? John Jenkins at Amazon, he went on record last year saying 10 deploys a day, that's nothing, right? We do one deploy every 11.6 seconds, right? So that's a mean number of deploys per day of around 23,000 deploys a day. So that can be as large as entire environment deployment. It could be as small as a content change. Yet, it doesn't matter, right? This is the sort of pace that they can actually sustain without causing, chaos and disruption perpetually downstream. So, I think what makes this so important to me is that the DevOps movement has figured out how to break the core chronic conflict. They figured out how you can actually get a fast flow of planned work while maintaining reliability and stability and security in the production environment. And I think one of the things that actually kind of irks me, and I'll actually share some prescriptive steps of how everyone can replicate these practices and get the outcomes that they've gotten, is that people will say, we're not Amazon, we're not Google, we're not Pinterest, we're a 100-year-old company. Right? And I don't think that actually matters, right? Wherever you have reliance on the IT value stream, DevOps is applicable. So it's not just the people who show up at the Velocity conference. It's financial services like BNY Mellon, Bank of America, World Bank, Paychecks. It's even in the retailers like the Gap, the GameStop, which is an interesting category because the analysts always said they're typically the technology laggards. It's even in the nonprofits, in the higher education. Any place where you see lots of cloud adoption, you're going to see DevOps practices. So what I'm going to do now is share with you what I believe are the 3 underpinning principles of DevOps. In this book, The Phoenix Project, a novel about IT, DevOps, and helping your business win. By the way, I'll share with you that later. Oops. Great. There's a kind of a Yoda, Mr. Miyagi-like character who speaks in the language of the 3 ways, of which our hero in the novel has to sort of figure out kind of the DevOps patterns. And so the 3 ways are the 3 underpinning principles of which you can derive all of the DevOps patterns from. So the first way is all about the left to right flow of work as you go from development into operation. And by the way, how am I doing here so far? Is this interesting? Can you give me a thumbs up? Okay, thanks. So the first way is all about left to right flow of work, right? And why dev and ops is because dev and ops are what's between the business and the customer, right? So the business says, here's where we need to go. That gets turned into requirements that go into work into dev. And only when it successfully transitions into service, right, have we actually delivered value to the customer. So the underpinning principles, right, that underpin the first way are understanding the flow of work, right? Seeing that work should go from left to right and only from left to right, right? Work should not go backwards. It should not be bouncing back and forth between the ticketing system and the defect tracking system, right? It should go left to right, and it should go to left to right quickly, right? One of the tenets of any process improvement is the notion of increasing flow. So in the DevOps community, we talk about high deploy rates, right? But a lean practitioner would probably say it's not about deploy rates, it's about lead time. How long does it take to go from code commit to in production, right? To get high deploy rates, you typically need lead times measured in minutes or hours, not months or quarters. And you can only do this if you never unconsciously pass defects on downstream. In other words, we have to design for the downstream step. And we can only do that if we sort of keep the global goals in mind, right, as opposed to local goals of feature completion rates, find fix rates, or availability. And Deming would call, once you've achieved that, Deming would say you've achieved profound understanding of the system. So the first pattern is almost a requirement for like how do you visualize work, right? And so manufacturing and lean, there's this whole notion, this whole movement on how do you visualize work. The question becomes like how do you categorize it so that you can actually visualize it. So Ben Rockwood, one of the leaders in the DevOps community, after reading the Phoenix Project, he said one of the things that resonated with him was that annual business planning sessions for the ops people or ops engineering is maddening because they think IT operations is this all-you-can-eat buffet. And so one of the things that he took out of this was that to break down all ops work into 4 categories. There's one, the obvious business projects. So those are typically tracked in the project management office. Those are typically mapped one-to-one with an application project, an application development project. But then there's all these other internal IT projects that they atomize into, right? It's like the puppet or chef automation, the internal, the automation process, the elevation of preventive work, right? Those are internal IT projects. Right, and often both of these atomize into changes, which typically live in the ticketing system, and then unplanned work. Right, this is sort of like the dark matter inside of IT operations, because whenever you have high amounts of unplanned work, they displace all the other types of work. So I think I'm hoping sort of like a key takeaway would be, look at your downstream peers in operations and say, just how much internal IT projects do they have? Right now, are we being fair about making sure that they have enough capacity? And then secondly is, how much unplanned work do they have? Typically, I've found that, in most ops organizations, they have 25, 35, 55% of time spent on unplanned work. And it can go as high as 110%, right? If you're spending all your time firefighting, right, you're not getting any sort of planned work done, right? And in fact, you're having to, even do overtime just to keep your head above water. So, that's the first pattern. So one question that I would just love to do in a little informal poll, and let me not ask this towards you, but towards your friends, right? How long does it take your friends to go from code committed to code in production? For your friends, how many would you put it in the league of minutes? Raise your hand. Hours? Weeks? Okay. Months? Okay, yeah, that's interesting, right? So, and by the way, I've been in situations where it has taken us months to go from code commit to successfully running in production. Right? So the question you should be asking is like, what is the ideal release rate, or would this actually be deploy rate? And so that's the gap. And so one of the sort of things that you would want to inspect in terms of how to close that gap is, for that amount of time, that lead time, how much of it is actually spent in queue versus in work? Meaning in queue is like when it's sitting in a ticketing system not being worked on, or it's sitting in someone's inbox and you have to go remind them, can you do this? Or we're just waiting in line for a virtual environment. Versus runtime, it's actually being run, like the machine operator is actually doing the operation, right? And typically, the amount of queue time is probably like 95, 99%, right? And so the way to reduce lead time, right, is not only to increase automation, but it's actually to tackle places in queue, right? And in Toyota plants, they actually have a role called the water spider. Well, they'll actually have a person transporting work from work center to work center, and they don't leave until the work is done, right? Sort of like a waiter. But the saying it is so important to optimize towards lead time, it's actually worth it to have someone, babysit the work. Okay, so the second pattern comes from this. How many people have been in a situation where you might be in a project meeting and say, we have to deploy next week, and then the ops guys freak out, saying, deploy what? Deploy that? Right? That's not even designed to run, let alone run in a production environment. Right? For an ops person, this feels very unfair, right? Because it means that somehow we're taking shortcuts in order to get into production. No one's been in that situation? Okay, great. I've been in that situation. And I think there are many reasons for this, but we believe that one of the root causes of this is that for not only the feeling of it's a trap, and the huge chaos and catastrophic deployments that can result from it, is because that the first time the environment and the code is actually run together is during deployment time. right? So the mitigation for this, the countermeasure, is operations must be responsible for creating a one-click, one-step environment creation process, right? So whether it's in Puppet or Chef or right-clicking something in the virtual management console, right, operations must deliver an environment that resembles production and make it available to developers as early as possible in the project cycle, right? In fact, right, by doing this, it has many, many positive benefits. One is that suddenly dev can actually now develop in an environment that resembles production. We can create an environment that's actually synchronized, where we have dev, test, and production all running and synchronized long before the big deployment begins. And this actually increases the ability for dev to actually onboard other developers, right? Because everything's in the environment as opposed to in our heads. So there's one, I think there's one sort of minor culture hack that we need to do to sort of really make this work, which is, in the agile policies, right? There's a wonderful tenet of, saying that at the end of every sprint interval, we have to have shippable code. I think, for anyone who's done, been a part of a catastrophic release, right? We know that that's not sufficient. We just need to modify it to say, at the end of each sprint, we must have working code and the environment that's going to run in, right? So now at sprint 0 or sprint 1, we actually have, we're actually starting to rehearse the deployment process. How am I doing so far? Am I making sense? Right. So this can have radically great outcomes. So in fact, we recently worked with the Puppet Labs folks, and we actually did what we call the DevOps survey of practice. And we actually captured something like 4,200 completed surveys. And one of the goals was actually to see if we could actually find the behaviors that predict performance. And we found that in the high performers, right, there were almost two things that were universally present and they were universally absent in the medium and low performers. And the two things that the high performers were doing that none of the medium and low performers were doing were these two things. They had infrastructure checked into version control, right, ideally in the same repo as the developers, and then two, they have some sort of automated way of creating the production environment, right? And it's not just production, it's prod, test, and dev. So those two things, right, at least in this early stage, we can say has a very high predictive capability to predict performance, that correlates with performance. So I think here's some scientific evidence that says these two things actually have they magnify performance. So the outcomes of putting the first way into place include having a single repo, ideally, where all the production artifacts can be checked into and be traceable, right? Ideally shared with development. We now are starting to create determinism in the release process. We now have a synchronized environment where dev, test, and production environments are all being created long before the big release. We're now starting to integrate the environment into the continuous deployment process. And this is what decreases cycle time, right? One of the formative moments for me happened in 2007. I was working with the CTO of Yahoo, and actually it was the CTO of AOL for this one. And basically, just by changing who was doing packaging, right, we were able to take the deployment times down from 6 hours for the AOL.com homepage to 45 minutes, right? So instead of the developers putting all the WAR files into a network share, right, and having the ops guys do the packaging, right, having QA actually be responsible for packaging before the test cycle is initiated, we drastically reduced the cycle time. And I think for me, why was that so important? Because this doesn't have to be a mega project, right? Doing small things, shifting responsibilities can actually create wild improvements in performance. And that's what results in faster cadence and shorter lead times. Any questions, comments, or concerns before we go to the second way? Thumbs up? Okay, thanks. So the first way is all about the left to right flow of work. The second way is all about the reciprocal, right? How do we take the learnings at the very end of the line, right, in production and InfoSec, and feed them to the very beginning of the line so we can actually prevent bad things from happening again, right, or ideally, enable quicker detection and recovery, right? So the principles or even the platitudes that underpin the second way are understanding and responding to the needs of all customers. So I think most communities are very, very good about saying, we know who the external customer is, but in the lean community, there's actually a thinking that says the more important customer, the most important customer for anyone is actually the internal customer, as defined by the next downstream work center, right? We almost have to do our work in a way, that optimizes for them. And I think the huge sort of breakthrough that happened in the manufacturing movement was something called design for manufacturing, where the product engineers said, our customers aren't the people buying Toyotas, right? It's actually the people on the plant line. And so let's make it impossible for them to over-tighten screws, put parts on backwards, right? And that not only improved quality, but also improved lead time and reduce cycle times. So we can only do that if we shorten and amplify all feedback loops. That's one of the things that underpin almost any process improvement methodology. And I think the best embodiment of this is the andon cord, the Toyota andon cord, where basically on top of every work center in a Toyota plant is a cord where if something goes wrong, if they get a part that is defective, or even if some operation takes 2 minutes and 10 seconds instead of the specified 1 minute 45 seconds, they're expected to pull the line, right? And that actually stops the entire production line. Trucks stop coming out the other end. Can anyone guess how many times the Toyota andon cord is pulled in a typical Toyota plant? Rough order of magnitude. Guesses? Mr. Discipline? 1,000. What? 1,000?
Only one time frame.
Oh, in a day.
Twice.
Yeah, I like your first answer better. So I thought at first the answer was 100, right? I was like, wow, that's amazing. 100 times in a day? It turns out, which was pretty astounding. Then someone else said, well, actually pointed me to an article that said in the Tennessee plant, it's actually pulled something like 3,300 times a day, right? So one of the questions is why? Why would they do that, right? Why would they disrupt production like that? And I think the reason is that for them, they know that it's better to stop the line, fix the problem, have everybody swarm the problem, than it is to have the defect go downstream and let technical debt accrue, right? So one of the questions I have for you, right, is as you're doing your daily work, right, how many times have you seen something that's not quite right that might be worth pulling the andon cord for, right? In a Toyota plant, that would be something like 3,000 times a day, right? And not all of them stop the line. Many of them just get escalated because they're that good. And so, by the way, that could be branches, someone checking in code that breaks the build, checking in code that breaks the unit test, someone breaking the deployment pipeline, right? All of these things warrant stopping the line because this is what enables us to create quality at the source. And by even solving these problems, create knowledge and capabilities where we need them. And that's all about the second way. So I guess one of the best embodiments of the second way came from Patrick Lightbody. He was the founder of a company called BrowserMob. It was one of the first sort of cloud-based load testing tools. He said, we found that when we woke developers up at 2 a.m., defects got fixed faster than ever, right? I love that, right? Because it says, and not because I'm a fan of waking people up at 2 a.m., it just says that people now have to live with the downstream consequences of decisions we make, right? So this is the way to share the pain and amplify and shorten the feedback loops. And this is absolutely, I think, consistent with 30 years of research into manufacturing processes. We have to create those feedback loops. And I think one of the best examples of this came from Google. This is a picture of Tom Limoncelli talking to the Lisa group in New York. And he said, at Google, they have this policy where dev must initially maintain their own code for 6 months, right? And so they actually have this thing called the handoff readiness review. And I think the question is why. So I think the reason is that Google, one of the scarcest kind of talents that they have are the SRE core, the site reliability engineers, right? So these are like your Uber sysadmins. In the head of every major properties, they have a core of these SREs. And it's some of the hardest people to find. And they're saying we can't afford to squander SRE cycles on crappy code, right? And so they have this thing called the handoff readiness review process where not only do developers have to manage their own code for 6 months for them to actually be eligible for the HRR, but then they have to go through this sort of like review of like what's their page alert, what's their monitoring profile, what's their system architecture, show me your release and deployment process, show me your defect counts, and I love this vague one. Show me your production hygiene, right? In other words, like, are you fit to even be, cohabitating with someone else, right? And before you pass that, we can't afford to have this code be in production and be managed by someone else. And so what happens if something goes into production and then gets fragile, right? Because those things do happen, because the downward spiral even happens at Google. They have something called a handback, right? Whereas, like, even if you pass the HRR, right, you hit a certain threshold, basically it goes back to the developer saying, thank you, but no thanks, come back when you're ready. And I'm not quite sure if they actually have to do a 6-month period of self-managing, but I think the important part is the handback. So I think it's a great way to sort of keep both sides accountable. It's a great way for ops and dev to hold each other accountable. So the outcomes of the second way, when we put patterns like this into place, right, is that defects, things like security issues, get fixed faster than ever. Right? We're now, once we sort of create that process, we can actually replicate that for the other value streams, for the other projects. And by the way, one of the things I love about Agile is the notion of user stories, right? Because once you have a culture that has a habit of generating user stories, we can create something adjacent to that called the ops user stories, right? Actually saying, in order to get to production, here's what ops needs to do. So in order to get a highly available environment requiring a clustered server, we can say, oh, here's the story deck that, that represents that set of work. And here's the resources we need, here's how long it takes, right? And we can actually now use that to help sort of budget our time to actually sort of take into consideration everything that's required to get to production. And when we do stuff like this, all groups are communicating and coordinating better, but more importantly, everyone's getting more work done. Comments, questions, concerns before we go to the third way? Okay? Thank you. Yes?
So, you talked about, like, waking people up in the middle of the night to, like, fix a problem.
Oh, no, it's just wake people up at 2 a.m.
Yeah.
No, kidding.
Do you think that sometimes that also builds crappy code because all they want to do is go back to bed?
Later in the day, you're going to hear a whole session on this from, is it the Chargify guys? You're going to hear a whole talk on this. And I think it's not, it doesn't create animosity. I think it creates a notion of a shared goal, right? The goal is not to just complete the feature, but it's not actually working until it's working reliably in production where it doesn't work, wake people up at 2 a.m. And so I don't see, in my experience, it actually is the glue that sort of makes operation and dev share the same values because they share the same goal. Does that answer your question? And can anyone look at the schedule and say who's going to be talking about this later today? I can't read my writing. Yes, 3 talks from now. Yes, I'm looking forward to that. Any other questions? Okay. So the first way is all about the left to right flow of work. The second way was reciprocal, it's the work from the feedback loop from right to left. And the third way, I think, is actually, upon some reflection, is actually in many ways the most important. So the third way is creating a culture that allows continual experimentation and learning. So it means, I think, 2 things. One is creating a culture that says it is expected that everyone in the organization take risks, do experiments, and learn from the successes and failures, right? But it also says that repetition is a prerequisite to mastery, right? So why do we need this? We need the first because we need a culture that's comfortable with breaking the rules, right? For those of you who have spent any time in large organizations, right, there may be a change management process that we've done things the same way for 25 years, right? How do we say, if you think there's a better way, try it, right? Now, how do we say that that's not only tolerated, but that's expected? But the second part is, so that's what allows us to push into the danger zone and get improvements. But the second part says that we have to understand that repetition is a prerequisite to mastery, right? There's a whole school of thought now that says, regardless of whether we're talking about sports training, learning to play a musical instrument, training in the special forces in the military, that only by repetition do we create habits, and there's habits that change the outcomes. So it's better to practice 15 minutes a day every day than it is to practice 3 hours once a week, right? And so, think about like the habits that we have when we have the test pipeline break or the continual deployment pipeline break, right? How good are we at fixing those? And what we want to do is do painful things more frequently. In fact, that's my next slide. So one of my favorite quotes that embody this came from Adrian Cockcroft, the cloud architect at Netflix. He said, it is our goal to do painful things more frequently so that we can make them less painful. And even though that we make it a pain in the ass for developers, right, they actually thank us because they know we're going to make rollouts go more smoothly in the future. And I think one of the best examples of this, right, came on April 11th, 2011, actually April 22nd, 2011, when in the first big Amazon EC2 failure, right? And so a friend of mine named Josh Corman, he was actually giving a talk at Source Boston, and like in the middle of his presentation, everyone looked at their phones and then left, right? And the reason is this, right? Like everyone who had any sort of reliance on Amazon, had a critical service go down, except for one organization, right? And that was Netflix. Right, and so everybody was asking, what is it that Netflix is doing that resulted in such a different outcome? And they wrote this seminal blog post entry, like many of their blog posts are, saying, I think it said 2 things that knocked me out of my chair. One that said, we made a deliberate design decision that said we could never rely on Amazon for availability. They will never be there when we need them most, right? And so the second engineering tenet that came out of that was that in order to survive failure, we made a decision that we had to fail all the time. And that's when they said, described Chaos Monkey, right? So, for those of you who haven't heard of Chaos Monkey, it is this incredible, audacious thing they do where they have on every production instance in the cloud, they have something called Chaos Monkey that randomly kills processes and entire compute instances, in production, right? They are deliberately injecting fault into the production environment, right? And you can imagine, right, once you do that a couple of times, right, suddenly you have really great, reliable, resilient operations and code, right? And so the thing that they don't actually talk about, which I think is actually probably pretty important, is that not only do you have Chaos Monkey running in production, but they also run it in test at a far higher rate, and in the code that development is using, right? So I think the lesson here is whenever you can break things in production, you should. Whenever you can sort of test assertions, right, do it. And it's not just for code and the logic paths in code, right? It's also for enforcing consistency. So asserts that you should be thinking about, right? And there's a great talk on this later about test-driven design for infrastructure as code. Man, what a great program, Mike. Thumbs up. I'll be here all day. Is any place where you can check for consistency of code, environments, and configurations, do it, right? Because if you can catch it before it goes into production, that's far better than catching it in production, right? And also test in production as well. And any place where you can actually do things like static code analysis, do it as early as you can in the dev process instead of waiting until, quote, the test cycle. So I think there's one prerequisite that we need to talk about because doing Chaos Monkey without this just causes chaos. And this tenet came from Marty Kagan. So he is actually a hero in the product management realm. His claim to fame, well, actually, what he says to everybody is that everyone must reserve 20% of their capacity, whether it's dev or ops, for the retirement of technical debt, right? 20% of all cycles must be taken off the table, never to be used for features, for the non-functional requirements. So why would people believe him? It's because he inherited the eBay product management organization in 2002, right? And he said, how good do you think, he said, for people who don't reserve 20% of their time to retire technical debt, you are doomed to spend 100% of your time paying down technical debt, right? And as proof point of that, he said, imagine how it feels as head of product management to say that you have not shipped a new feature in a year and a half, right? So, pay debt down now or pay it forever going forward, right? And so this is how you can go from an organization that goes from here to here, right? If you can generate the collective will to say, we're going to take 20% of our cycles, pay down technical debt, and do the hard re-architecture problems, make things more loosely coupled, right? Make things less fragile. That's how you get to here, right? Where things become less fragile. Now we can actually make things easier to deploy. This is how you break the downward spiral, right? This is how you actually fund and protect your DevOps initiative. There's actually one last benefit that I think now we can expose to the businesses that we serve, which is that it's not just an innovation culture inside of our, the DevOps value stream. We actually want it to happen, in the product management realm as well. So there was a quote that Scott Cook, he's the founder of Intuit, and he's been pushing this thing for like 6 years called the rampant innovation culture. And when I saw this, I freaked out. He said, by installing a rampant innovation culture for our TurboTax property, they did 165 changes in the middle of peak tax filing season. So, I'm not sure if you find that audacious, but I came from an environment where, for our customers that were retailers, they wouldn't touch production from October 1 to January 30th, right? Because they were so afraid of a change that might impact production. And so this lunatic made 165 changes during the peak tax filing season. So why would they do that? And I think the reason that one, they had great operations. Two, is this. By doing this, they were able to increase the conversion of their website by 50%. Right? So had they waited to the end of the, after the conclusion of the filing year, right, they might have already lost a customer, never to be able to get them back. Right? So there's this huge business advantage in not only enabling quick experimentation, but also saying for the business and the product managers and product owners, right, we need you to be doing experiments too. Let me share with you one more hack, and then I'll conclude. So I have become a huge fan of Kanbans. I love Kanbans. I wish I'd learned about them 10 years ago. And I think there's a wonderful way that you can actually modify Kanbans to actually to enforce this practice. So, in this Kanban board, you can imagine each lane is something like the specification has been created, it's in work and in dev, it's ready for test, it's release ready, and it's now into production. And ideally, you want the cards to march from left to right as quickly as you can. Yes? I'm sorry, Kanban board. A Kanban board is one of the tools and techniques they use in a Toyota production plant, where every unit of work is a post-it note or a card, right? And basically every kind of functional group or person has their own lane, right? And so the cards should flow from left to right. So if you have like an agile storyboard planning process, I would say that sort of looks like a Kanban board, right? But you want to take this all the way across the value stream, from feature in work, in your backlog, to feature, ready to be tested, feature in production. Did that answer your question? Okay. So one of the things you can do, right, is say all the user features are in yellow, but all the non-functional requirements are in blue, right? So now you can see from visual inspection, are there 20% of the cards blue, right? And more importantly, are they also marching from left to right quickly, right? Because until it's in production, we haven't actually created value. So, and by the way, for those of you who aren't familiar with Kanbans or you aren't using them, it's probably made one of the most meaningful improvements in my life, right? Because it helps keep everyone accountable, keeps all work visible, right? And it sort of encourages like a team behavior. It's like when someone's stuck, if a card's been stuck for 5 days, everyone will swarm that problem and figure out what can we do to help that person, get that card to the next lane. So why do I think this is important? I think it's two reasons. One is this downward spiral. This downward spiral happens everywhere, right? And I think it's just a side effect of the way dev and ops are typically organized. Whenever you have developers making decisions that cause defects downstream that impacts their lives, right? You're going to see this. And so when that happens, for the people downstream, that's what creates this notion of this feeling of hopelessness and despair. And I think this is actually this is very important to me, right? I mean, I can think of years of my life where I would take problems home with me. I would wake up every morning. Right now, I'd be clenching my teeth all night, right? It affects us, right? To deprive someone to change the outcomes of their life is actually one of the worst things we can do to a fellow human being, right? So I think one, it's an important human problem, but two, I also believe that this is a huge economic problem as well, right? I mean, and let me just flip it around. The economic value of fixing this problem is enormous. One of my co-authors of the DevOps cookbook, and he's the most recent Shingo Prize winner. We did this calculation where we want to find out how much value is on the table for us to be able to recapture if we could have the amount of waste associated with the IT value stream, right, and be able to redeploy that in a way where we get 5 times the value. The number we came up was $2.6 trillion, right? $2.6 trillion a year, right? That is a huge number, right? That is more than the entire economic output of Germany. So, the way I think about it is like, think about like what that will do to standards of living, think about what that will do to productivity, think about how much we could get more done, right? $2.6 trillion more. But also, the way I think about it is, when I think about the world that my children will inherit, my 5-year-old, my twin 3-year-olds, right? This will make a meaningful difference in the world that we'll inherit. So for me, I think it is a huge, enormous problem. And if we were presenting to business people, we'd say, there's $2.6 trillion on the table that someone's going to get, right? This is a zero-sum game, right? So either fear or greed, we need to go after that, right? As Deming said, survival is not mandatory. So if I could wave a magic wand, right, everyone will see or at least be conversant with DevOps practices and recognize them when you see them. I'm hoping that you'll see, and the fact that you're here today says that you think this is important, potentially important, but hopefully you'll see how this could be very important to you personally. I'm hoping that you'll leave with some concrete steps that you can actually put into place and get the outcomes that I've described. And I guess the most important outcome for me would be that you actually have the experience of being a part of a DevOps team where you have genuinely shared outcomes and you are actually genuinely working together to kick ass. I just came out with a book called The Phoenix Project. The full title, it's a novel about IT, DevOps, and helping your business win. And I guess one of my favorite quotes for this, I've been working on this book for 10 years, and it was very closely modeled after a book called The Goal. Has anyone here read The Goal? Okay, awesome. This is actually one of my favorite books on the planet. I mean, of all the books that have influenced my career the most, it's this book called The Goal by Dr. Eliyahu Goldratt. And it's a novel about a plant manager who has to fix his cost and due date issues in 90 days, otherwise they shut the plant down. And so even though I never worked in a plant or managed a plant, right, I knew that there were some learnings in there that were very important to me. And so one of our aspirations was to write essentially the goal, but for the IT context. And that's what this book is all about. And one of the most gratifying things for me is that many people are saying this is the goal, written for the modern age. But one of my favorite testimonial for this came from Jeremiah Shirk. He leads a DevOps initiative at Kansas State University. And he said, there are 3 types of books. One is a novel that you give to a friend because you think they'll enjoy it. There's a second type of book you share with work colleagues, right, to create a shared understanding. And then a third book you give to your boss to plant the seeds of a big, dangerous idea, right? This book is all 3. So our goal is really to positively impact the lives of 1 million IT workers in the next 4 years. One of the things I genuinely believe is that storytelling is the most powerful mode of communication. Whenever you're trying to convince someone to do things in a way that they might not be comfortable with, right? Storytelling, studies have shown over and over again, that's the most effective route. If the goal is to get mirror neurons firing in the other person, right? Storytelling kind of bypasses all the rational parts of the brain. And so to help make this possible, we're actually making the Kindle version of the book free until midnight tonight. And so I'll tweet out the link for this. But until like 11:59 to midnight tonight Pacific time, the Kindle version of the book is available for free for anyone who wants it. After today, if you want to give away a 170-page excerpt of the book, just go to this download, just give it away, right? And I think, for me, I've found it the stories I love the most are the ones where someone said, I gave this to my peer in operations or in development, and now suddenly we say, everyone said, that is us, right? These things are happening to us, and now we're talking about how we can work differently to put DevOps practices into place. If there's anything, I'll share with you a couple projects I'm working on. If these are interesting, just email me. We're working on something called the DevOps Defensive Audit Toolkit. One of the things that we found with DevOps is that auditors freak out, right? This whole notion of separation of duty where developers are deploying code by themselves, right, in production, right, will freak out 99% of developers. We're trying to develop the paperwork that you can do in advance to actually show developers that you actually have a system of internal controls where the risks are managed. If you're interested in that, let me know. We're collecting enterprise DevOps studies. If you're interested in that, let me know. And if you're interested in an early draft of the DevOps cookbook, let me know. And just make sure you put down something like audit, enterprise, cookbook. With that concludes the prepared part of my presentation. Thank you very much.